Don't know if I have audio. I'm going to try talking my way through this one. First, we have our equation. Y equals negative 1/2 the cube root of x plus 1 minus 3. First thing they want us to do is they want us to identify the amplitude, well, A, H, and K. In this case, A is negative 1/2. H is negative 1. Remember, we take the opposite of what we see right there. K is negative 3. Okay. So far, so good. Now, one of the things they're asking us to do is to graph this, so we're going to need our table of values. Alright, so we get this, starting right there. This is a cube root function. Now, I know we've had a little bit of argument, a little discussion over this, and then some confusion, but because it's a cube root, I want to start with x's of the following. So I'm going to pick negative 8, negative 1, 0, 1, and 8. So I only need 5 terms to graph. Now, of course, they're asking why those. These are the first perfect cubes. Remembering that this graph is going to take a shape like this. Follow the pen. It's going to make it look a little curve through first and third quadrants. So what we're going to do now is remember that little thing we've talked about where I said we take x plus h, which in this case will be x plus negative 1 or x minus 1. So I take each of the red numbers, which are my normal function numbers, and the normal ones I use for a cube root, and I subtract 1 from each one. So that gives me minus 9, minus 2, minus 1, 0, and then finally 7. Alright, so far so good. We can try to apply the other idea of using the range for a standard cubic function, which in that case, the cube root of 8 is negative 2, cube root of negative 1 is 1, the cube root of 0 is 0, cube root of 1, 1, cube root of 8 is 2. Again, as I've said, I'm not sure if this works every time, but so far it hasn't failed. AY plus K, which in this case will be negative 1/2 y minus 3. Okay. So we'll try that. I'm moving for a little bit away. I'll grab my calculator. We can plug these into the calculator. That's the main idea. So, as you can see, there's the calculator. We'll turn it on. We'll clear out what we were playing with before. So this is negative 1/2. Now I need my, whoops, cube root function of x, which in this case is going to be negative 9 plus 1. Push my arrow to move out, minus 3. That gives me my answer of negative 2. You can see mine's still doing it to 4 decimal places because I didn't tell it not to. Again, if we were to use our little equation over here, we take negative 1/2 times negative 2. Negative 1/2 times negative 2 is going to give me 1. 1 minus 3 is negative 2. So that still works. But we're going to continue using just the calculator. Now, I'm going to change that mode. And we'll go scroll up, hit enter. Now the TI-84s will work very similar to this. You may not have the direct scrolling function. You may have to use your second function key. But like I said, check your instruction manual. It'll always show you. I plug this one in. This one gives me a fraction, negative 5/2. Some people asked on the test, will we be able to use decimals? I'll take decimals on the test, just because not everybody has this nice little calculator. That gives me negative 3. Scrolling over. That's negative 7/2. And then at long last, we'll plug in 7. All right. That gives me -4. All right. So I can take this away. Now, for those of you who have it, remember, the TI-84s work very similarly. Turn it on, go into my y equals mode. As you can see, I've already done this one, so it gives me that. Now, I'm going to go in here and I want to say graph the table. Well, now you're probably noticing I got the same table values, but usually it comes in and has all this stuff filled in. Use your second function, hit table set, and you can go in there and you want to set this to ask. By setting it to ask, you're telling it, I want to tell you what values. As you can see, I plugged in the 5 values that we had originally picked. It spits it out and gives me done. Then if I hit graph, it shows me my pretty little picture. Okay. So let me graph this one by hand, and we'll see how that came out. As you can see, the x values cover a wide range. The y values don't cover as much, so I don't need quite as big or quite as tall a y-axis. One, two, three, four, five, six, 7, 8, 9. So of course you can tell I've actually gone and made my axes too long on one side and too short on the other. Okay, so there we go. So let's plot -9, -2. So it's all the way down here, and that's right there. -2, so it puts it right there. That's -5/2, which is really -2.5. So that's like right about there. -1, -3, 0 is at 3.5. 7, 1, 2, 3, 4, 5, 6, 7. Down 1, 2, 3, 4. And 7's all the way out there. That -1/2 has made this graph really, really shrunk down. So now the fun part is trying to connect the dots with a nice, smooth curve. And there we go. This is the solution to number 6. No, I'm sorry, this is number 5 on our answer D for the review for the quiz tomorrow.